Good morning, girls. Today we want to start with new chapter 14, Temperature and Heat. And the first lesson is about temperature. Objectives, what we are going to study and learn in this lesson. First of all, we want to know how temperature is related to kinetic energy. And we want to know how to convert between Fahrenheit, Celsius, and Kelvin scales, and to know about transferring of energy. We will take one by one and we will study it. Let's start. Look at these figures here in front of you. What do you see? You see different objects, right? By looking only at these objects, you can know if this object is hot or cold. So, for example, here we have sun. We all know that sun is a hot object. Fire, desert, ice, snow. Only by looking at this object, you know if it is hot or a cold object. The definition of temperature is what? Temperature is a measure of how hot or cold something is. Okay? So it is a measure of how hot or cold something is. This is the meaning of temperature. Many decisions are made based on temperature. Every day in the morning before you go to school, you check the temperature, you check the weather outside to know what to wear. So it's important to know the temperature before we leave our houses. If you feel that you are tired, you are sick, what do? You measure your temperature using a thermometer to know if you're okay or not. And we have so other things we need temperature for it. We have here a simple lab. I hope that you all try to do it at home. Try to bring different materials put them in front of you on a table. Small piece of metal, wood, plastic foam, rock, plastic, anything, cardboard, different materials, the same as this image. Okay? Put them on a table for 5 minutes. Then with your hand, with the palm of your hand, not your finger, the palm of your hand, try to put your hand on each material alone and put it on metal. Try to feel the temperature of metal. Then put it after that, remove your palm. Wait a little bit, then put it on what? On wood and so on. Okay? Then try to see or to list the materials in order from coolest to warmest. You will feel that not all of them have the same or exact temperature, okay? You will feel that there is small difference between them. After you finish, I will ask you two questions. Which material felt the warmest to your hands? Which material had the highest temperature? Why do you think some materials felt warmer than others? Was your hand a good thermometer? Now, if you bring a thermometer after you finish and try to measure the temperature for each material, you will see that the temperature is the same for all of them. So, why? Why? When you put your palm on it, on the material, you felt that each material is not the same as the other material. Okay, we will see that later at the end of this lesson. Temperature is related to the kinetic energy of particles. Temperature is a measure of the average kinetic energy of the particles in an object. We took average kinetic energy before. Kinetic energy is energy of motion, energy of moving objects. So temperature is related to kinetic energy. Now we said before that all particles in the material, in any material, any substance, they are what? Moving all the time. So they have kinetic energy. The atoms and molecules in an object, they are moving and vibrating, so they have kinetic energy. Now what is the rule? That as the average kinetic energy of particles in an object increases, it means that this object is a hot object, that the temperature of this object increases. So if you look here at these two different materials, you see that the particles here, they are moving with a long arrow, more distance. What does it mean? It means that this is a very hot object. How did you know? Because we said when objects are moving faster, it means the particles are moving faster. It means that the kinetic energy of the particles is higher, so the temperature is greater. Okay, look at this other material. The particles are moving slowly, just small distance. So slow motion or slow motion for the particles, so the kinetic energy will be less. This object is a cold object. Okay, here is another example. If I bring for you these two boxes and I ask you, what do you think? Which one has a high temperature? Which one has a low temperature? Direct, you look at the motion of the particles. Here, the particles are moving long distances. It means they are moving very quickly, very fast. So, more speed, more kinetic energy, more temperature. This is the hot object and this is the cold object. Okay? Good. How do we measure temperature? Now, our hands in the previous simple experiment that we did, we said you put your palm on each material. Now, okay, you put your palm, you will feel if it's hot or cold, but you can't give an exact temperature. You can't say that it is 25 Celsius, it is 30 Celsius, 15 Celsius. No, we can't give this number exactly. So what do we need? We need an instrument, we call it thermometer, to measure temperature accurately. Okay? This is an example for thermometer. We have so many types for thermometers. This is one of them. Now, thermometer is an instrument that measures and indicates temperature. This is the definition for thermometer. So it's an instrument that measures and indicates temperature. To measure temperature, we use a simple physical of substances. What is this property or physical property of substance? That most substances expand when their temperature increases. This is very important. Most substances we have them, they expand when temperature increases. Why, girls? What do you think? Think with me. Now, we said that when temperature increases, the kinetic energy of the particles will increase. Kinetic energy, it means the particles will move faster, will push each other more, they will push the surface of the object. So what will happen in this case? They need more volume, so they will expand. That's why when temperature increases, substances, they expand, okay? Because they need more volume, more space. The particles are push each other more and more. So from this property, we use it in thermometers. Some types of thermometers use the expansion of liquids such as mercury or colored alcohol to measure temperature. Most of the time inside the thermometer here, they use mercury or colored alcohol. Why exactly these two substances? Because these liquids expand quickly as their temperature increases and contract quickly as their temperature falls. That's why they chose these two materials, mercury and colored alcohol. Now, all substances, they expand, but these two materials, they expand faster. Just a small increase in temperature, they expand a lot, so you can take the accurate reading. Okay, so as here is a thermometer. If I, for example, I want to measure the thermometer, I want to measure the temperature of any material now or liquid. As the temperature rises, the particles in the liquid inside the thermometer gain kinetic energy. For sure, temperature starts to increase, the particles will gain kinetic energy, so the kinetic energy will increase, they will start to move faster, so the liquid expands and rises up the nanotube. They move faster, they push each other more and more, so they need more volume, so they expand. The liquid will expand. Okay? Now we want to talk about temperature scales. We always hear Celsius, Kelvin, Fahrenheit. These are temperature scales, okay? These are the The three commonly used temperature scales: Celsius, Fahrenheit, Kelvin. The Fahrenheit, Celsius, and Kelvin temperature scales are commonly used for different applications in different parts of the world. Okay, these are three different thermometers with three different scales. This one, Kelvin thermometer, Celsius thermometer, and Fahrenheit thermometer.